no longer with Intuit. He's with Novus Labs. He's a co-founder and head of engineering. A small company, but I don't know if he's going to talk about the company, but definitely he will talk about EKS and how you can do a great job with EKS. Welcome, Shri.
Thank you. Thank you. Hey, everyone. Thank you. All right. So yeah, we will be talking about EKS and talk a lot about machine learning on EKS. If you want to know more about Novus Labs, I'm here after the talk, and we can talk more about this. I'd love to hear from you about your machine learning journey, and if there are ways in which we can collaborate, that'll be fantastic. So here is a quick agenda for the talk today. I'll give a quick introduction about myself. We'll talk a little bit about this machine learning on Kubernetes online meetup. A lot of these lessons that I'm going to talk about, the lessons from the community, those lessons are actually from that meetup. We'll talk specifically like technical details of what people typically do when they run machine learning workloads on EKS, the lessons that are learned in that process, and then we'll talk a little bit about the non-technical challenges that also come up very commonly when people talk about machine learning in general on Kubernetes, or actually all machine learning productionization workloads. And of course, there's going to be Q&A. I'm going to be here after the talk as well if you have more questions after that. So a quick introduction about myself. As I said, my name is Shri. I'm one of the co-founders and head of engineering of novuslabs.ai. Before this, I was at Intuit, where I ran a Kubernetes-based platform team that had over 300 Kubernetes clusters running anywhere from 10 to 15,000 DC2 instances. I got into Intuit through an acquisition of a company called Applatix, which was the founding company for the Argo project that is now very, very famous in the Kubernetes community. All right, and as I said, a lot of the learnings about machine learning and Kubernetes that I'm going to talk about today are actually part of this ML on Kubernetes meetup. I run this meetup. We meet every alternate Tuesday at 9:30 a.m. On Zoom, and we have a conversation about the intersection of machine learning and Kubernetes. This is a QR code that you can scan, and it'll take you to a Google Doc that has the details, that has these very details. I also have a bigger version of this QR code at the end, so it's okay if you don't have to scan it right away. But as I said, it's an online meetup. It's free. You come in and you discuss technology. Like, you find other people who come in with questions about something specific about their machine learning workloads or about their machine learning platforms, and we discuss these conversations. Other people come in. We have participants from from India, from Europe, from the East Coast, and of course from here in the Bay Area as well. All the sessions are recorded. So if you scan this, it'll take you to a Google Doc which has a list of all the YouTube links for the recorded sessions. All right, so that takes us to the core technical part of this conversation. Like, we are talking about machine learning on EKS, and people are going to talk about, okay, what does it mean to run machine learning workloads on EKS? If you want to get started with this, I'm sure one of the first things you will run into is going to be a conversation about Kubeflow. Kubeflow is an open source project that was pretty much started with the intention of running machine learning workloads on Kubernetes. And there are good things about Kubeflow. There are some not so good things about Kubeflow. You will, as I said, it has a lot of presence in the amount of material written about it. So when you start discussing or investigating how to run machine learning on Kubernetes, you will land up with Kubeflow. One of the best things about it is it was from the get-go meant to be an all-in-one platform. It has everything that you would need for machine learning setup. So it has things about everything from notebooks to model servers to a UI and various other operators for kind of running, whether it's TensorFlow jobs or MPI operators and stuff like that. So that part is good about it. Like, it has pretty much everything that you can potentially think of in terms of running a machine learning workload. But there are some not so good things about it. And one of the first things that you will probably encounter is the fact that it has a very, very complex setup. Like, deploying Kubeflow on Kubernetes involves like deploying some giant number of YAML files, most of which might work, but some of it may or may not work. It may be about components that you don't care about, and therefore it becomes very, very hard to kind of get to debug something if something goes wrong, or kind of figuring out how is something really actually working, or introducing other dependencies that you may or may not even know about. about. Like for example, Kubeflow deploys or requires you to be running a service mesh, which you may or may not be required to do, which you may or may not want to do in the first place. So there is a fair bit of complexity involved. It's not the most efficient in the way it is actually set up and run. It has limited flexibility. So this example that I gave you about that, it deploys like, so here is a quick architecture diagram of Kubeflow that's published on the Kubeflow website. It has all these different components. And let's say I don't want the MPI operator, which is something that is typically used for HPC style workloads. But then, it's not very easy and straightforward to stop Kubeflow from deploying this MPI operator. There is limited flexibility in kind of configuring this, limited flexibility in kind of picking and choosing what you want, what you don't want, stopping something, upgrading it is like a whole separate conversation at some point. So it is good in the sense that it has many different things. The not so good part is all these other kind of gotchas that come with it. So then what, right? Like, sure, okay, so Kubernetes is great. I want to run machine learning workloads. I look up Kubeflow. Kubeflow may or may not be the best one to use. So then what do I do? The next option actually is to build your own machine learning platform on Kubernetes. And there are many, many good things about it. The most important one being that you have the flexibility and the grow as you go part. That you don't have to start with this. You don't have to start with saying that, okay, if I'm deploying a machine learning platform, I'm going to deploy like what this looks like, 25, 50, 30 different components. You can start with something super basic. You can say that, oh, what do I need? My data scientists need Jupyter notebooks, so let me deploy a Jupyter notebook service or Jupyter hub on Kubernetes. And just with that, get started. And then you can say that, oh, next thing I want to do is my data scientists need a place for them to store their models when they create it. So let me deploy a model registry, which is like MLflow is one of the more common open source model registries. And then you can think about something else that you need. And then, so one by one, step by step, you build the platform as you go. And then you use components that you care about, that you know what you're getting into. Debuggability is much more easier because you know what you're getting into. And then you can reuse several components that are used with ML and not with ML. I mean, there are things like, let's say, for getting IAM roles for every pod in your clusters. That's a very generic feature that you want irrespective of whether your workload is running machine learning or not. A caching service. You want an internal cache for caching data. This might be something that ML benefits from, but various other workloads also might benefit from it. So you can reuse components, which is actually a good thing. The manageability of this is really, really nice because you're kind of building things as you go, and you're doing things that you know are required for you and important for you. What are the not so good things about it? Well, the first and foremost thing is definitely it's going to take slightly more time. If you have to go and deploy 30 different components, one by one, understanding all of them and deploying them and running them is going to take some time investment. The good part, though, is that this time, I think, is well spent because you know what you're getting into. And then the second thing is that the fear of eventually, will I be building another Kubeflow? Like one by one, step by step, like in 3 years from now, will I land up having Kubeflow again? Most likely the answer is going to be no, because it's probably unlikely that you will have all the kinds of potential workloads or all the kinds of machine learning models that typically MLflow caters for. So most likely you will have a subset of what MLflow does, but this subset will be very, very relevant to your needs, and that will be a good thing. So there are some maybe not so good things, but I think overall, like building your own machine learning platform on EKS is actually a really good thing. This is a very, very high level, simple kind of overview of what you might land up doing. So there are 3 types of kind of workloads if you look at your Kubernetes clusters. There'll be one which are workloads that are pods that will be running your ML specific things. So you will have your Jupyter Hub pods that are used for a notebook service. You will have MLflow for your model registry. You'll have Kserve or Seldon, which is like, these are components used for model serving, and you deploy them as and when you need it, and as and when in the way and configuration that is important and relevant to you. There are parts in the middle here which are kind of overall generic things that Kubernetes provides for any workload. This is great because this is where you can reuse these kinds of features for machine learning and otherwise. And then as of, it's pretty evident that you're not just going to run machine learning workloads on Kubernetes by itself. It's almost always going to need access to other managed services. So you will need access to S3 and DynamoDB and Redshift and what have you. And Kubernetes is great for that, like setting up the IAM roles for your workloads running in Jupyter Hub to access S3. Those kinds of things are much more streamlined if you have them running on Kubernetes. And there are well-known, well-defined ways of doing this. So running these workloads on Kubernetes and accessing managed services is actually a great thing. So building these workloads, building this internal ML platform on Kubernetes is a great option. As time goes by and as you see more and more people and more companies, more and more use cases, you will come up with slightly more advanced use cases where you need a feature store, where you need GPUs and you need to have model servers that are specifically used for GPUs. But you don't need to start doing them right on day zero. You can build as you grow. So what are the lessons that we've learned from the community about this? Like, I'm sure it's great to build your own ML platform. This is pretty much what people who join these meetups have told us, have mentioned this, have brought in these problems and said, tell me what I should be doing if I'm running into this particular problem when I'm running this internal ML platform on Kubernetes. So as I said, the first thing is, yes, it's absolutely true that there are lots and lots of people who build their own internal ML platform on Kubernetes. They typically use these kinds of workloads. There is a project called Zero to Jupyter Hub, which specifically talks about running Jupyter Hub notebook service on Kubernetes. So they use that kind of a service for installing and running Jupyter Hub. There is MLflow, which is an open source project for model registries. So that project, like deploying and running MLflow on Kubernetes, works great. And then one by one, people kind of deploy all of this. And the common benefits of using Kubernetes for auto scaling and better cost management, better efficiency, better visibility, all of those kind of sort of come in for free. What more? Beyond this, what do people run into? So one of the things that keeps coming up is the amount of time that is spent by teams doing feature engineering work. Essentially getting access to data, cleaning the data, transforming the data, and using it in a way that eventually is usable in my machine learning model. There is a lot of time and effort that is spent into doing that. Kubernetes is awesome for this. EKS is awesome for this. You can use various different kinds of tools and services like Argo workflows, or running just regular cron job pods or cron jobs in Kubernetes for running pods that kind of fetch data, clean it, transform it, dump it somewhere else so that your next stage of your machine learning pipeline can take over from it. Sometimes this effort is needed twice. You do this effort during model training, and then you do this effort again during model serving, which is not ideal, but that is something that does come up. Kubernetes scaling features work great for batch and real-time workloads. So this is, again, there are often times where either this the data cleaning jobs, or even actual machine learning inferences. Like think about a marketing use case. Think about the last time you got an email from Gap.com saying that they have a special offer for you. The way it actually happened is last night, someone ran, or some batch job ran, it queried a bunch of like 100 million Gap customers and found out specifically which users to target for a specific campaign that they have based on a machine learning model and those emails who got sent out. That batch job, or those kinds of batch jobs, are great for Kubernetes because Kubernetes can scale up the number of pods, scale up the number of nodes, like the talk that we heard before about like how you can auto scale pods, nodes, everything, and these can run completely independently of any human interaction. So these Kubernetes scaling features work great. And then my favorite learning from these meetups is about use of GPUs. GPUs are meant to be these processors for massively parallel processing and very efficient, massive parallel processing. And my understanding of this was that GPUs would be great for model training because by definition, models get trained with large amounts of data. So if you have like 100 million rows and you want to train a model, yes, you use GPUs for it so it's faster and more efficient. But I was very surprised to learn that GPUs actually get used even during inference time. So even when you have, let's say, one photo that someone clicked and it's sent to a model and said, classify this photo as a cat or a dog. For that, you can use GPUs, and people do use GPUs for it. one use case for GPUs is what is called embeddings. In machine learning terms, embeddings is a way of converting data into an array or a vector of floating point numbers. And this array of floating point numbers then gets sent to the model for training and so on and so forth. And this conversion of raw data into this embedding or into this vector of floating point numbers can take a lot of time. One of these companies, let me move to the next slide. One of these companies that we spoke to, or one of the persons who joined us in one of these meetups is from this company called Cookpad, and they talked about use of GPUs during inference time. They had a problem of converting images into an embedding at runtime. It was a user-facing application, and previously, so the thing upstairs, the window upstairs talks about like the time that they were spending in converting an image into this array of floating point numbers. It was taking about 300 milliseconds earlier. And they decided to use GPUs, and you can see that with the use of GPUs, the processing time went down by a factor of 15. So what was earlier 300 milliseconds is now like suddenly being done in 20 milliseconds or so, which was fantastic. And use of GPUs as during real-time inference of these machine learning models was amazing. It was one of the best things that we learned during these meetups. And there are ways to do this in a way that is cost efficient. There are ways in which you can do this without actually changing like some major setup in the way you write code. And a lot of that was covered as part of these topics. So I have links to this. This will be shared with everyone, of course. I have the links to the talk, a KubeCon talk that they gave, and also to the ML on Kubernetes meetup. When they came in, they presented this, and there was a lot of discussion about how to go about doing this. So one other thing that comes up, so use of GPUs is great, use of Kubernetes is great. The last point here talks about the fact that all the teams that you typically talk to, all of them talk about how they strive for seamless automated model and feature deployment. Like there is a lot of conversation about machine learning and ML ops and comparison with DevOps and how application development today and the way applications are deployed and run, and it's so automated with CI and CD and everything. Teams strive to do that for ML workloads as well. But the fact is that it does not actually always pan out. And the reason for this is that there are these non-technical challenges that come in the way. And of course, there's some technical challenges, but there are a lot of non-technical challenges. The most common that keeps getting talked about in the community are these. Like the first and foremost, data scientists want to focus on data science. Like they are these kind of math, experts, and that's their education, that's their vocation. They want to do more data science. That Jupyter notebook in which they write Python code, that's their happy place. And if at the end of that, if after creating a model, if you suddenly tell them to now go into a different world where they are talking about pods and YAMLs and HPAs and VPAs and God forbid DNS configuration, like they are lost. They're like, I don't want to do this. I'm happy creating my machine learning model. So they want to do more data science work. Kubernetes, EKS, and all of these things are slightly more complicated for them. The common way people address this, or companies address this, is by pairing data scientists with machine learning engineers or someone with like a more traditional software background. And the ML engineers in this case kind of take this model, convert it into a containerized application, and then deploy it on Kubernetes, or containerize this and run it on SageMaker or what have you. And this is good in theory, but there is a lot of kind of back and forth that has to happen between data scientists and these machine learning engineers. And there is a lot of context that if I am the data scientist who created a model, there's a lot of context in my head about why I picked a certain type of a model. Why did I pick a hyperparameter to have a specific value? Why did I choose a specific type of pre-processing step? And that context has to now be transferred from the data scientist to this machine learning engineer so that they can replicate this in a production serving environment so that your actual application serving this model is actually going to like do the same thing. And that is inefficient. There is this lot of implicit context, and there's a lot of back and forth, and that's why one of the problems is that there is a lot of time that is spent between a machine learning model getting created and that machine learning model being actually served in production and delivering business value. This commonly handled way of doing this using processes is one of the reasons why there is like inefficiency there. We believe that this should be a problem handled through technology and not necessarily only with processes. There'll always be processes, but there should be a way to kind of deal with this even with technology. And that's actually one of the problems we are trying to solve at novuslabs.ai. So I want to talk a little bit about like the stuff we are trying to build. I would love to hear from you. If you have questions about this, we can have that conversation. But from the community, like these are the things that keep coming up. That, we love Kubernetes. The ML engineers talk about how they really like Kubernetes. Lots of people discuss and build internal ML platforms on Kubernetes. They build everything from the experimentation platforms, model registries, actual model servers, and then kind of, advanced features like feature stores and, GPU usages and stuff like that. Kubernetes offers a great platform for actually handling or accessing managed AWS services like S3 for these machine learning workloads. In fact, it can be fairly seamless, especially if companies and teams use IRSA, in which you can get an IAM role for a pod. There is very little that the user has to change. They directly get access to, their pods get specific IAM roles, and those IAM roles can directly access S3 or any other AWS service. And then, as I said, ML teams want to do more, want more automation, but it actually does not pan out as of today, at least, because they continue to grapple with significant challenges around collaboration and productionization because of kind of either the skill sets or the complexities of kind of each of these domains. If you think about data science as a domain and then infrastructure as another domain, and there is very little that is kind of at the intersection of both of these. And that is why kind of models keep taking a lot of time to be productionized and to be delivering business value. So yeah, as I said, most of these learnings are based on this meetup that we host. It's based on Zoom. I'd love to have all of you join this meetup and share your understanding of machine learning and share your machine learning stories or learn from other people in the community. This QR code here is for the ML on Kubernetes meetup. If you scan it, you'll go to the Google Docs page, which shows you the specifics of the Zoom calls and whatever other details needed for joining the meetup, and that's just a QR code for my LinkedIn profile. Questions? Yeah, so the question, if I'm not wrong, is there are tools that are specifically focused on for data scientists to be able to use, but those tools themselves behind the scenes can deploy AWS managed services like S3 or whatever, create S3 buckets or whatever. What about those? Again, those tools are great for running on Kubernetes. In fact, one of the meetups, like pretty much I think 2 or 3 meetups ago, we actually had a session on Metaflow on Kubernetes. Very much in this. So one of the founders of Metaflow, who used to work at Netflix, he came to this, he showed a demo of Metaflow's integration with Kubernetes. So behind the scenes, so typical use cases with Metaflow, you add a decorator to your Python functions, and in the decorator, you express what you want. So you can say that for this particular function, I want you to run this in a pod that has, say, 2 cores and 6 gigs of memory. And behind the scenes, Metaflow is able to take it and deploy it in that pod, in a Kubernetes cluster with a pod with that configuration. That's great, because that way, again, users can use, the data scientists can have their code written in a format that doesn't change, but all they have to do is add these things. But at times, again, the question then becomes, would they know? Specifying memory and CPU probably is the easier of the options, but if you want to have that pod have a specific IAM role, run it in a specific namespace, if you want it to have a specific environment variable mounted in it, or a specific volume mounted in it, one by one, are you going to ask your data scientists to kind of know all of this? Or is it easier to say that, okay, you write this notebook and then we'll create another version of it, which the MLE does and says, I'll add the decorators. It's going to depend on every company and every use case, but there are efforts made to simplify this a little bit, but it doesn't seem like there is a lot of easy ways in which this has been solved for everyone, at least. So good. So the question is, what's the cost of building, I guess, your own internal platform on Kubernetes?
Yeah,
is that right?
I'm concerned about, AWS, how much will charge?
So the cost actually, if you're going to build your own internal ML platform on Kubernetes, the cost is going to be proportional to the kinds of workloads that you're actually going to run on it. So if you're going to start off with just having, let's say, a Jupyter Hub-like service, which gives you a centralized notebook environment for your users, the number of users you have and the number of notebooks that you actually run, that will define the size of your clusters, which defines the size of your cluster footprint, and therefore the cost that is incurred in it. So that's actually another good part of building your own ML platform. It is as big and therefore it's as expensive as you want it to be. because you have full control over it. You can start with something as simple as having a few additional pods, which is not going to cost a lot more. Or you can start off with something really big and say, every user in my company will have their own notebook and it's always there, it's always running and so on. So a lot of these projects also talk about optimizing for costs by, for example, the Zero to Jupyter Hub service talks about shutting down these notebook pods once they are done, or after 2 hours of downtime or something like that. So it keeps the costs low so that you only pay for what you use. Thank you. I think I'm going to have to take. I'm going to be hanging out here. If you have more questions, we can, meet, outside or after the next talk, and I would love to answer more questions. Thank you.